Hello everybody, hello, we are back once again. So in this video we are gonna be doing calculus, the equation of a what, of a tangent. So now we'll be discussing what, tangents. Okay, so now what is a tangent? A tangent is a line, or is a what, a straight line which do what, touches a graph at only one point. Okay, and at that point we call that point a what? At that point where it touches the graph, it is what? The point of intersection, the point of contact, sorry, the point of contact. So now check something. The tangent can touch a parabola graph. As you can see here, I have two different graphs here. I have a parabolic graph, which is this one, and a cubic graph, which is this one. Okay, so now let's start with the one for parabola. A tangent, since it is a straight line, it can touch the parabola where here. This is the point of contact. So point of contact. On this point of contact, there are coordinates there, x and y. Okay, or it can come like that, because a tangent is a straight line, so it can be what, negative also. It has a what, it can have a negative gradient, because a straight line has a positive and a negative gradient. Is it fine? Or it can come like this and do it here, or like this. Okay, but the most important thing, it is the what, the point of contact. Another thing is that there can be a tangent where at the point of contact, at the point of inflation, it can be something like that. Because now at the point of inflation, it is where your graph changes its concavity, right? But there's a situation whereby the tangent can pass there. So the important thing about this concept, you must have the coordinates of the point of contact, and then the gradient, you are sorted. So now in this question, in this concept, they will ask you to determine the equation of a tangent, or determine the values of a and b given given the gradient, or the what you call the point of contact coordinates. So let's start now. Now there's something that I always use. Okay, so now this is what I use so that you can remember it. This one, it is the what, gradient function. What is the gradient function? The gradient function, it is the same as our derivative there, dx, or first derivative, just like that. Okay, so what do I do? Now just make it as a table, as a what you call inside the box, and then this first derivative, it is equals to the what, the gradient. Is it fine? So the first derivative of x, it is equals to the gradient. Remember, a tangent is a straight line that has what, a tangent, right? So now the first derivative of this graph, it is equals to the gradient of this straight line. The first derivative of this what you call this graph there, of the graph which a tangent is passing through, is passing at that point of contact, it is equals to the gradient of that straight line, where it can be a parabola, it can be a cubic graph. Just know that the first derivative of that graph there, which is given, it is equals to the what, the gradient. But now there's something there which is I have to tell you, where at a certain x value, so this one x value, you'll be what, given. Is it fine? You'll be given, or you'll have to do what, to calculate it. Even this one, the gradient function, now it is the one for the what, for the equation. So it can be x cubed or x squared, blah 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 blah. So now there's something here, and then the gradient, now you will be given, or you'll have to calculate it there. Is it fine? This is the main important thing there about this topic now. So now when you are discussing these three things, if they give you a equation whereby they are saying blah blah blah, and then you find out that the gradient, the first derivative, okay, check something, you find that your equation, it is like x cubed plus what you call px squared, and then minus qx, and then maybe they will say plus 5 there. Is it fine? So as you can see, this graph, it is what, it has variables there. Okay, and then now in such scenario, In such scenario, you will be given what? The gradient and the what? The x value. So now in this this concept, you will be given only two things between x value and gradient, or that thing. So as I just said right now, that you will be given what? The gradient. Like it will be in the form of like y is equals to mx plus c. They will give you the equation of that tangent, and then they will say at x it is equals to maybe 4. But now the equation of a cubic graph will have what? Variables. That's why it will be given the gradient, because m will be available, maybe 6x plus 4. And then you'll also be given the x value there. Is it fine? Or you will be given the gradient function. The equation will be y is equals to x squared plus 4x maybe plus 6. You are given. And then the x value you'll be given there. But you'll not be given what? The gradient. So you must always use this thing and check what you have and check what you do not have. That is that. So the main thing is to know how you're gonna work out your thing. So now, without wasting time, let's start with what? My example. So I'm gonna write my example here, and then you're gonna continue, guys. Is it fine? But before I continue, there's something that I have to tell you before I forget. Ne? Here it is the thing here. 9 in that. So this one and this one is the same thing. At this point and at this point, the gradient, it is equals to 0. At maximum or minimum, the gradient, it is equals to 0. So in the statement of this question, whereby they're saying that it is a minimum of what, maximum or minimum, know that that thing that I just showed you here, this thing here, when they said minimum or maximum, simply note that you're not gonna write your first derivative. You're simply gonna say what? First derivative of x, it is equals to 0, because you know from what I just told you that the first derivative. So now from the table that I just wrote there, the first derivative of x, this is what you must start writing. It is this equals to m. After that, you say first derivative of x, it is equals to 0, and then that is when you now put what? The first derivative given on that question there. So now under such cases, the gradient is equals to 0. Okay, so let me prepare a good question, and then we'll now do different scenarios. Here's a question. They are saying that determine the equation of a tangent of the graph. So now you are given what? F of x is equals to negative 3x squared minus 4x plus 5. Is it fine? So now you can see that this is what? A parabola graph. Parabola. At x it is equals to 1. So before you start doing your thing, simply do what I did there. So now I had what? The first derivative, which is equals to the gradient, okay, and then which is the same as m there, and then that thing, the x value. You must check now. After that, since you did that thing, check what you have. Do I have the first derivative of x? Yes, I do, because my equation which is given there doesn't have variables. Do I have the gradient? No, I do not have. Do I have the x value? Yes, I have the x value, because they said at x it is equals to -1. Now you can start. And as you can see there, you know that for you to find a tangent, and a tangent is a straight line. First thing first, you must have the what? The gradient. Second thing, you must have what? The coordinates, or the point. So now we are gonna start now. The first thing first, it is what? First derivative of x, it is equals to m. What is the first derivative of that thing? -6x minus 4 equals to m. Is it fine? But where at x is equals to -1. Please note that first derivative of x only takes the x value only. When you're dealing with the first derivative of x, you do what? The x value only. Now we are gonna substitute. It will be -6, and then what? -1 minus 4, it is equals to m. Therefore my m, it is equals to minus it is 6 minus 4, which is the same as what? As 2. The gradient, it is 2 there. So now check something there. At this point of contact, I'm getting my graph is like this. Is it fine? It's a set graph. No, this one is wrong. So according to the graph given, this is what I have there. Okay, so now this is a set graph, right? So now this tangent now has a positive gradient, meaning that it is going where? Like that. Can you see it? and then this is the point of contact. But at the point of contact, I only have the what? The x value only, which is what? -1. Can you see it? So now I'm left with what? With the y value now there. Is it fine? So now we are forced to find what? The y value. So now check something. Now, since we have the equation, it is y it is equals to -3x squared minus 4x plus 5. Now, since I have the x value, I can simply do what? Substitute -1 where? There is what? X there. Therefore, my y will be equals to 6. Now I'll be happy because at the point of contact, it is what? -1 and what? 6. Is it fine? This is what I have now. Can you see what I'm talking about? So now I'll write the root, or at the point of contact, I have -1 and 6 there. But they said they want what? The equation of the tangent. I already found my m. I already found the equation, the points there. Now I can do my y, it is equals to mx plus c. Let's substitute. Y it is 6, 2 m it is 2, x it is what? -1 plus c. Therefore c it is equals to 8. -2, when it goes to the other side, you add. So therefore my equation it is y is equals to 2x plus 8. Can you see how easy it is? Can you see how it is? So now in this question, they said they want the equation of a tangent to the graph. So now I said the first thing that you must do, you must check what you have. Because I said when you are doing this thing, this triangle thing, it helps you and determine what you have and what you do not have. And I said that they usually give you 2 things only. And I checked that I have the x value and I have the first derivative because my equation doesn't have variables, but I did not have the gradient. But according to the question, they said they want the tangent, meaning that I had to find what? The gradient and the point. Okay, so now I had to find my gradient as 2 as I did there, and I said whenever you're dealing with the first derivative, you to put what? -1 only. After that, I realized that on the point of contact there, I only have -1. I do not have what? The y value there. So I had to calculate it and got it there as what? 6. And then now these are the coordinates for the what? Point of contact, -1 and 6. And then now I have the gradient and the point. That's where I got my equation of a straight line. Then I got my answer there. Is it fine, guys? That's how it is. Yes. Now after that, since we have did this the first scenario, let's go to the second scenario whereby you have the equation that has variables, whereby they will say determine the values of a and b. Now we are going to do what? Simultaneous equations now, and then you are going to try and move on to the other things. So that is how you simply do it. It is the same thing, even if they're saying find a and b, it is the same thing. So let's move on. Now here's the second question, second scenario. You can pause and try it out, but now let's go. G of x is a tangent. So now it is the equation of the what? Of the tangent to f of x, which is this one. And already I can see that there's what? A and b missing. Okay, at x is equals to 1. So now before we continue, let's do my thing there. Now let's go. What do I have? Do I have the x value? Do I have it, guys? Yes, I do. I was given. Tick. Do I have the gradient? Yes, I do, because I have the equation of a tangent. Because on the equation of the tangent, the value of m it is what? -8. Mara, do I have the first derivative? Like, can I use the equation given to find the first derivative? No, I do not, because there is what? I'm a variable. So now I am given what? 2 things there. Can you see how we do these questions, guys? Now we are gonna move now and do what? And do this question now. Let's go. Now let's start. The first thing first, you do what? First derivative, it is equals to m. So first derivative, it is equals to m. Now what is my first derivative there? 3x squared plus 2ax plus b. It is equals to -8. Where at x it is equals to 1, because I was given there. I always said that the first derivative only deals with what you call the x values only, right? And then after that, that is where you're gonna have my what you call 3 1 squared plus 2a1 plus what we call b, it is equals to negative 8. After that, we are going to have what? 3 plus 2a plus b is equals to negative 8. Therefore, let's make b the subject. B is equals to negative 11 minus 2a, equation 1. Can you see it? After that, we are going to continue now. Is it fine? Now check something there. This is what the what you call the cubic graph, right? And then now it means the tangent, it is like this. Okay, so now at the point of contact, I have what? The x value only. I do not have the y value only, meaning that I can use what? The equation of the tangent to get what? The y value. So y is equals to negative 8, 1 plus 20, which means y is equals to what? 12. So at the point of contact, I have 1 and what? 12 there. Is it fine? Now we are going to continue now. And then now, when you are using the first derivative, you put the x value only. When you are now using the original equation, you put both x and y. So let's go. Y, it is equals to x cubed plus a x squared plus bx plus 18. Now we are going to substitute both x and y. So where there is y, put 12, it is equals to 1 cubed plus a1 squared, ne? And then what? Plus b1 plus 18. Is it fine? Now I have 1 plus a plus b plus 18. 12 that side. Okay, so now let's go there. It is gonna be what? 1 plus 18, it is what? 19. 12 minus 19, what is it? Let me find another marker. This one will give me a problem. These things. So now I have a plus b, so plus 19, right? 12. Then it will be a plus b, which is equals to 12 minus 19, it is what? Negative 7, right? And then b is equals to negative 7, negative a, equation 2. Can you see it? Now we are simply going to equate b is equals to b. Negative 11 minus 2a, it is equals to negative 7 minus a. And then let's take this 2 to the other side. It will be minus 1 plus 2. So it will be what? Minus 1 plus 2. It will be, so let's check something here. I can use my calculator because minus 1 plus 2, it is positive 1, so 8 there. So negative 11 plus 7 is what? Negative 4. So my 8 is equals to negative 4. Can you see it? And then now for b, I'm going to choose between the two equations. It's going to be what? B is equals to negative 7, negative a. Now it's going to be b is equals to negative 7, negative 4. So therefore, my b, it is going to be equals to negative 7 plus 4. It is equals to negative 3. That is how you deal with what? With the equation of a tangent. Now looking for what? For the values of a and b. Did you see how we did it, guys? It was just fine and easy there. So now in this question, let's just go back a little bit now. In this question, they said they want what? The values of a and b. We were given the equation of a tangent, but it is a negative gradient, okay? And then after that, we simply checked what we have. I have the x value and the gradient, but I did not have the first derivative because this one, it is what? It has variables. The first thing first I did, I found what? Let me just start here. I simply found the y coordinate at the point of contact because I didn't have what? The y coordinate at the point of contact since I was given the x value only. After that, I found the coordinates at the point of contact. Then I did my first derivative of x is equals to m, substituted a 1 where there is x and did the first equation there, okay? And then made b the subject. And then on the second thing, I used the original equation, which is f of x, and substituted both x and y, which is 1 and 12. And then I got my a is negative 4, b is negative 3. That is how it was, guys, okay? So thank you very much, guys. I hope you enjoyed and understood everything we did on the session. We are gonna do the last one of minimum and maximum things. But it is just the same thing because what you call it is the same concept. But before I continue, let me just give you let me give you 2 questions, and then you'll just give me the values of A and B or the answer on the comments there. Okay, but thank you guys. Here are your questions. Find A and B if f of x it is equals to ax squared plus bx plus 5 has the tangent at x is equals to 1, and then it has the equation which is negative 7x plus 3. So that equation, it is the equation of the tangent. Number 2, the one that I wanted us to focus on, a function g of x which is equals to ax squared plus b over x has a minimum value. You see, minimum, the one that I said the gradient it is equals to 0 at x is equals to 4. The function at x is equals to 4 is 96. Find a and b. Basically meaning that the coordinates, this is now what minimum, it is the what, the turning point. So it basically means the coordinates here, it is what, 4 and what, 96. Okay, so that's all guys. Thank you very much. I hope you enjoyed.